welcome back. In this video, I want to talk about this idea about co-functions, and essentially I will be talking about co-function identities. Guys, these are pretty simple, but one needs to actually see them, and one needs to like use them. Once one understands them, then one has to kind of use them to solve some examples. Guys, first we are going to look at these co-function identities, and then we are going to use them to solve some examples. So to see how these co-function identities work and what they basically are, we are basically going to draw a right angle triangle, and from that right angle triangle, guys, we're going to be able to define, or we are going to be able to talk about the co-function identities. One of the concepts that is connected to a co-function identity, guys, is called the idea of complementary angles. And what are complementary angles? Basically, complementary angles are angles that add up to 90 degrees. Guys, you may already know that there's two types. There's complementary, where two angles add up to 90 degrees, and there's supplementary, where angles add up to 180 degrees. Okay, in this case, the co-function identities are more closely connected to complementary angles. So let us draw a right triangle, and from there we can define these co-function identities. Let us say we have a right triangle right here. So guys, this is right angle here, and let us call this angle theta. So if I call this angle theta, then this is going to be a complementary angle to this angle right here. Why? Because we know that the sum of the angles of a triangle is 180 degrees. So this is already 90. Then sum of these two is going to be 90 degrees. And we know when the sum of the two angles is 90, that means they are complementary angles. So if this angle is theta, then this other angle is going to be 90 minus theta. So guys, let me show you quickly the math of this. So we know the sum of the angles, theta plus this angle is 90. And let us say we don't know this angle, and this angle, let us call it beta. We know sum of all these three angles is supposed to be 180 degrees. Now, if we want to find the value for this angle beta, I'm calling this angle as beta. So what we have to basically do is we'll subtract theta and subtract 90 from both sides, like we would solve a simple linear equation. And so if I subtract from here, we got to subtract from the other side. So guys, what's going to happen? This is going to cross out, this crosses out. So beta, this angle that I'm calling that angle, is going to be 180 minus theta minus 90. 180 minus 90 is 90, and then I just have to put that theta. So that is why this angle is 90 minus theta, and theta and beta are complementary angles because they add up to 90. Yeah, because if I bring it to the other side, then it would be like beta plus theta, which is 90 degrees. That's why they are complementary angles. Okay, so guys, once I have this set up, now we can write the co-function identities, and let me call it the content, the topic here is co-function identities. Okay, so I'm not going to write all of them, because once you understand some of them, then you can we can get others just by using the basic rules for trig identities and basic simple trig identities. So let us start with the sine of theta. So the first basic co-function identity relates sine with the cosine. So guys, for this particular triangle, so let us say this side is, let us call this side as A, this as B, and this as C. Okay, guys, you can call it whatever you like. So I'm just using A, B, and C. So guys, sine of theta, we know from the definition, is the opposite over hypotenuse, is A over C. But that is exactly same as writing the cosine of 90 minus theta. And if you want to verify that, let us quickly verify. We know cosine of 90 minus theta, that means this is my reference angle for that cosine function. Cosine is adjacent over hypotenuse. So adjacent is still A and hypotenuse is still C. So since the right hand sides for both of these are the same, that means the left hand sides are supposed to be equal to each other. So the first co-function identity becomes that the sine of angle theta is equal to the cosine of 90 minus theta. Now this is one of the ways to actually see this from drawing a right triangle and then labeling the angles. Guys, when we actually talk about graphing these trig functions, then you can see it from graphs as well. Okay, that is the first one. Then the second one, let us say if I have the cosine theta, can I see is there a relationship between just cosine theta and sine of some angle? So guys, if I look at the cosine theta, it is going to be B over C. Similarly, if I do the sine of 90 minus theta, it is also going to be B over C. So what does that mean? That means cosine of 90 minus theta is equal to sine of 90 minus theta. So that's how they are related. They are co-function identities, right? Then the third one, guys, obviously we have sine and cosine. What about the tangent? For tangent, yes, we can go back here and we can extract it from there and see the relationship between tangent and something where we are looking at the other angle. That's one of the ways to do it. Guys, the other way is, and I think that would be a simpler way for co-functions. We know tangent is the ratio of the sine over cosine. So let me write that out, sine over cosine. That is something we already know. Guys, as I already told you in my earlier videos, those basic definitions are very important because everything that we are going to learn in this course kind of builds up on the previous definition. And I mean, that is true for mathematics in general. Everything kind of builds up on what we have learned previously, okay? So please make sure that you remember, you understand the basic identities and basic rules so that you are more confident and comfortable working with advanced ones, okay? So in this case, we can write sine theta as cosine of 90 minus theta. We have already verified that. And cosine of theta would be sine of 90 minus theta. Okay, so once I have that, we know cosine over sine is cotangent, and then it's not just a theta, it is 90 minus theta. So that becomes the third identity for a co-function. Tangent of theta is cotangent of 90 minus theta. Okay, guys, again, for me personally now, because I have been using these and I have been teaching these and working with these things forever, so I kind of remember a lot of these. But guys, if I don't remember them, and when I was a student myself, I would not really spend too much time on remembering this. What I would rather like to remember is, why do I get these from? So I remember I get them from a right triangle. We're working, all these trig functions are valid only for right triangles. So whenever I need them, if I forget them, guys, I'd like to draw a reference triangle or a right triangle for my reference. And then from there, I'm able to get all these co-function identities and a lot of these identities just by drawing the right triangle, okay? Guys, similarly, we can have cosecant. We know cosecant is the reciprocal of the sine. So if I have to write the co-function identity for a cosecant, then it's going to be 1 over sine. That means it's going to be 1 over cosine, and 1 over cosine we know is the secant. So you can figure out the cosecant, cotangent, and the secant based on these three. Okay. So guys, I'm going to stop right here for this video, and in my next video I'm going to take up 2 examples where we are going to use these identities, or maybe the other ones that we have not verified, or I have not verified here. And then guys, we'll be done with, I think this is the first section of the chapter, which starts by talking about the trig functions of acute angle triangles. And then guys, we're going to look at other examples. There's a lot of examples that we have to still look at. So guys, till then, take care. I will see you in the next video.